Alrighty, those questions, remember, after you answer them, we'll show you the correct answers. So this is kind of a second opportunity to check your work. You do have a first opportunity when you are working independently. All right, this first one is story problems. Remember, if we have words in our problem, then we're going to have to think about what's going on and come up with a picture in our heads. Read each answer choice below and choose the best answer to the question in the story problem below. Mrs. Rinaley baked a cake for the 3rd grade teachers. She wants all 6 teachers, so there's a cake and there's 6 teachers, to get the same amount of the cake. What unit fraction would represent the amount of cake that each teacher would receive? When I imagine cakes, I imagine circles. And then we've got 6 pieces. And 1 teacher gets 1 piece. So that is 1 out of the 6 pieces. The unit fraction is 1/6. Questions, concerns, or comments over that one? All right. Let's take a look at problem number 2. It says use the comparison symbols to compare the numbers. 500, 500. 9 tens, 6 tens. 9 tens is greater than 6 tens. So this reads 596 is greater than 569. Questions? We did pretty well on that one. I don't think there would be a lot. Let's take a look at our next one. This is one of those fun problems that says choose all that is true about this fraction. Remember, I taught you how to be a smart test taker. It tells you that this is worth 3 points. So in this case, all means 3. There will be 3 answers, okay? Look at the fraction below. Choose all that is true about this fraction. This fraction is 5/6. 1 more unit fraction would make 1 whole. That is true. If I were to add 1 more 6, that would give me 6/6, which we know is the same as a whole. So that is true. There are 5 pieces in this whole. Nope. A lot of you chose this. The key is there in this whole. The whole is 6. We only have 5 of those pieces. This is more than 1/2. That is correct. 6, half of 6 is 3. 3 and 3. Okay, so this is more than 1/2. There are 6 pieces in this whole. That is correct because their denominator is 6. Denominator describes the whole. All of the pieces in this fraction are not equal size. I'm glad I didn't have to come through the camera and scream at anybody, because if y'all didn't know that fractions were equal size by now, I was going to come mess up your room and tell your mama you did it. All right. All right. Let's take a look at 5. Type the missing number that makes this equation true. This means we have a number that should be right here. We don't know what that is. We do know that we're multiplying by 8s until we get to 40. So I'm going to use my song. You got 8, 16, 24, 32, 40. I had to sing the 8 song 5 times before I got to 40. So you should have typed the answer 5. 8 times 5 equals 40. Levin, a question about that one?
Remember that when we were doing that together?
I do. You got on office hours with me yesterday.
And but you were recording. So if you do come to our house and mess up our room, we have proof.
But I have editing powers of video. Dun, dun, dun. All right, compute, find the answer. 983, subtract 194. 3 ones, subtract 4 ones is impossible. See, look, 1, 2, 3. Where's the 4th one going to be? So we've got to regroup. So we're going to take 10 from the tens place, which means we now have 7 tens. And if we combine the 10 that we took and the 3 we already have, we have 13 ones. 13, 12, 11, 10, 9. 9 ones. 7 tens, subtract 9 tens is impossible. Look, 1, 2, 3, 4, 5, 6, 7. Uh-oh, where's 8 and 9 going to go? Nowhere, so we've got to regroup. So we are going to add 10, and we're going to take 10 tens from the hundreds. So we now have 17 tens and 8 hundreds. 17 tens, subtract 9 is possible. 17, 16, 15, 14, 13, 12, 11, 10, 9, 8. So we have 8 tens. 8 hundreds, subtract 100 is 700. So the answer you should have typed is 789. That is your answer. We feeling good? And we're feeling good. All right, folks. Let's hop into our graphing. Where everything sits an old song. You're right, Camille, it is an old song. You're right, and it's helpful to us. All righty, folks. Today, we're going to continue on with that graphing and data conversation. I was very, very, very impressed by you yesterday with the information that you turned in on your categories and your titles. You had that vocabulary down pat. To make sure it sticks in our head and stays familiar, we're going to take a look at our data vocab. Data, 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 data.
Yeah, y'all. A lot of people talking about data. Yeah. Data. Let's get into it, y'all. Okay. Let me kick off this conversation. What's data? Well, that is information, numbers and facts telling you about something. Yeah. And there's a lot of different types, so let's jump in. Let's go. Data could be the number of kids who go to your school and what their shoe size is. Or it could be info about a thing like a book. What does it smell like, feel like, or how does it look? Okay. These are called an object's property. What you need to know to understand what it is properly. We can use data to get answers, like how many kids in your class are good dancers, or how do students feel about the new playground. There are 2 types of data, let's break it down. There's qualitative data, and that refers to an object's qualities recorded in words, and quantitative data that's measured in numbers, like something's height, weight, age, or temperature. Now when you're gathering or collecting data, then you're taking measurements and notes and making observations. And some data you can collect on your own. For example, that plant that you're growing in your home, if you want to know how much it grows each week, take a ruler and measure it, record and repeat. That's data. Yeah, the facts and the numbers telling you about something so you can understand what it is. We use data to learn and answer questions about the world as it turns. That's data. Data, 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 data. That's data. Data, 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 data. Whoa. Okay, so you want to find out information about a group, like all the students in the 3rd grade. All you gotta do is ask them a bunch of questions, and then you got yourself a survey. Ask questions that apply to the whole population. Every single 3rd grader in this situation. Say you want to know the average 3rd grader's height, but you can't ask them all, that would take all night. Take a random sample of 3rd grade kids. Random means they have an equal chance of being picked, which means the sample represents 3rd graders as a whole. And the larger the sample size, the more accurate the result. Now, once all your information has been collected, and you have all the answers to your questions, you have a data set. It has everything you need. With so many measurements, it can be hard to read, so we need to analyze it, present it in ways that demonstrate answers to any questions raised. You can organize your data with a graph or a chart. It displays different kinds of data like art, line plots, pie charts, and bar graphs are 3 ways to organize the data that you have. Make sure they have titles. And what else? Let's see. The X and Y axes must be labeled correctly. Make sure that you display the data in a way that tells the right story and what you're trying to say. You don't want to make a graph that makes all the kids laugh. When you're using data, you gotta do the math. That's data. Yeah, the facts and the numbers, telling you about something so you can understand what it is. We use data to learn and answer questions about the world as it turns. That's data, 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 data. That's data, 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 data. Whoa.
Woo! All right, data and data, kiddos. That's what we're taking a look at today. On your seesaw, you have a new activity that has been unlocked to you. It is called Lesson 7-1, Data and Graphs. Okay. With your teacher, we're going to watch the teaching video, one we have just done, and we're going to complete slides 1 through 5 on our practice work. We'll discuss examples and be ready to share with your class. And you guys are going to work on slides 6 through 10. Okay. Go ahead and click on that add response, please. And it says lesson 7-1 with your teacher. This is what the first page looks like. Okay. All right. Students in Jorge's class took a survey of their favorite cereals and made this graph to show the results. Name at least 3 facts about the information in the graph. Okay, so here's the graph that was created. Our directions have asked us to name at least 3 facts about the information in the graph. So let's look at this information here. What can you guys tell me about this information in the graph? What is one fact that we could write? One fact we could put about the data in this graph. Data, data, data. Anyone? Anyone? Leah, what can we write?
That it is a picture, because it's not tally marks, it's a picture.
Fact 1, this is a pictograph. Let's write that out. Fact 1, this is a pictograph. I'm going to put it over here to the side, style, side. Fact 1 is, this is a pictograph. Okay? So this information is shown in a pictograph. Now let's talk about how to read pictographs. There is a scale. I want a fact about the scale. Who can tell me something about this scale down here? What is it teaching us? What is the scale?
Are we writing this?
You are. Aiden G, what is our scale down here? What are we counting by?
So we're counting by 2s and 1s.
2s and 1s. Very
And
good. Pictograph.
so since it shows so it shows 2 spoons, that means it equals 2. And 1 spoon equals 1.
Awesome. So on pictographs, we do see sometimes that half of a picture represents half of the amount. When the spoons are crossed, that picture is showing us that this counts as 2 votes. When there is a lone spoon, that is counting as 1 vote. So fact, the scale counts by 2. The scale counts by 2. I want to use the scale to come up with a fact about Berry Crunch cereal. Berry Crunch cereal. See if you can count up how many students voted for Berry Crunch cereal. And what fact do we have about the number of students who voted for Berry Crunch cereal? Josh, take a look at Berry Crunch cereal. The double spoon counts as 2 votes. The singular spoon counts as 1. How many students voted for Berry Crunch cereal?
8.
8 is here. 2, 4, 6, 8. And then we have 1 spoon left over. So what does that make it, Josh? 9. That's right. That one last spoon counts as 1. So 9 students voted for Berry Crunch cereal. And I'm okay with that because it sounds like Captain Crunch berries, and that is a wonderful cereal. So fact 3, 9 students voted for Berry Crunch. There are a ton of facts that you could have put about this graph, tons of them, okay? But these are the 3 that we chose to focus on here. Steve Rogers.
It's only 4 kids. Oh, I was looking at the wrong place.
You were looking at honey granola, right?
Yeah.
Yeah, honey granola does have 4 votes because it has 2 double spoons, 2, 4. But that is a fact you could put down. You could put down that 4 students voted for honey granola. That information is shown in our graph. I have choppy robots on my Zoom today. Choppy delayed robots. Where are my students? What have you done with them? All right, let's go ahead and take a look at slide 2. Slide 2 is going to show you the data that's going to be in the video that we are going to watch. So this is a picture example of what you are getting ready to see in the video, okay? The question that the video is going to answer is how many teams are in the East Falls League, okay? Let's take a look at how to solve information with graphing here. Ooh, maybe. Where's my play button? And play. What? Cord. If you're joining us on YouTube, the play button's not working, so we're talking about our video in person. I apologize for my voice. It's not as fun as the textbook video. All right, so first things first, we're going to look at the key. The key is the same thing as scale. Everybody say key.
Key.
Key. I can see your mouths.
Key.
They're not moving. I can see them. Key. Okay, now everybody say scale. Okay,
Scale.
now everybody show me your hand and say key. Say key.
Key.
Now everybody show me your other hand and say scale.
Scale.
Now marry them. Key and scale are the same thing, okay? When we're talking about graphing, a key is what we count by, a scale is what we count by. Marry them. So if I say key, what do I mean? I'll see y'all are scaring me. Everybody take your hands again. Say key. Say scale. Get them together. Okay, if I say key, what do I mean?
What do you mean?
Scale.
Scale.
Scale. Say scale, what could I mean? Key. Okay, so key and scale mean the same thing. Okay, so when you hear me say key, you don't have to say, Miss Sousa, what's a key? Because you know it's a scale. And when you hear me say scale, you don't have to say, I thought we were talking about the key, because you know they're the same thing. Okay, key, scale together. All right, so we're going to look at that. There are 3 hockey stick doubles and 1 half hockey stick. Okay, so East Falls League right here. East Falls League, there are 3 doubles and there's 1 single. The 3 doubles represents 3 times 2 because our key or our scale tells us we're counting by 2. 2, 4, 6. The half hockey stick represents 1 because what is half of 2? 1. Okay, so that would be 2, 4, 6 plus 1 is 7. So 6 plus 1 is 7, and there are 7 teams in the East Falls League. Okay, this is how we just look at counting. Everybody look at C over here. This is a different type of problem. In this problem, we're comparing which is greater and which is lesser. How many more teams does the East Falls League have than the South Falls League? So I already know that my East Falls League is 7. We just counted that. So I don't have to redo my work. I'm going to work smarter, not harder. So I already know the East Falls League has 7. It's asking me how many the South Falls League has. Let's count. There are 2, 4. So the South Falls League has 4. And I know that again, it's showing me East Falls is 3 times 2 plus 1. South Falls is 2 times 2, which was 4. Okay? So now we subtract. The East Falls League has 3 more teams than the South Falls League because 7 subtract 4 gives us 3. So that's where that answer came from. Okay, you with me? All right, let's skip over that bottom section and move on to 3 so we can get you guys working. Let's read this little blurb up top. A scaled bar graph uses bars to represent and compare information. Okay, so now we're not talking about pictographs anymore. We're talking about bar graphs. We've switched, okay? The bar graph shows the number of goals scored by different players on a hockey team. See our categories? Number of goals is going on the side. And our players' names is a category going along the bottom. So Alex's goals are in green. Cindy's are in purple. Jack's goals are in orange. Reggie's goals are in pink. The scale shows the units used. Okay, so our scale, look right here. What are we counting by? 0, 4, 8, 12, 16, 20. Y'all know
Fours.
by 4s. Right, that's why we learn those multiplication songs. They can help us with scales. So we can always tell the scale by looking from 0 to the first number that's listed. And that's counting by 4s because 0 to 4 is 4 numbers. 1, 2, 3, 4. Okay. On this bar graph, each grid line represents 2 units. Let's take a look at what that means. We just said we're counting by 4s, but look right here across, going halfway up. That's a grid line. What's half of 4? 2, because 2 plus 2 equals 4. Okay, so that's why that grid line in the middle represents 2. Every other grid line is labeled 0, 4, 8, and so on. For example, the line halfway between 4 and 8 represents 6. So let's look at this line here that I'm going to put in blue. Okay, it's halfway between 4 and 8. So if we're counting by 4s, and we're starting at 4, 5, 6. That's halfway between. 6 would be halfway to 7, 8. Okay? So we're counting by 4s, but it is possible to count by 2s if you count each individual line. Terrence, a question about that.
Are we writing that? Are we doing that, or you're just showing how you're doing it?
If it helps you, I'd like you to write it.
Okay.
Okay. All right, so this part, guided practice, everybody's writing this. So get your pen ready, get your favorite color. We're all writing this. And 1 and 2, use the bar graph above. There's the graph we're using. How many goals in all did Alex and Reggie score? I want you to take your pen and where it says and, I want you to put a big old fat plus sign. Anytime in graphing, it's asking about and, it's telling us to combine or add those 2 totals together. Okay? So when it says how many did Alex and Reggie score, it's asking for Alex's number plus Reggie's number. Okay? Alex and Reggie. So let's take a look at Alex and Reggie on the graph. We're going to have to see what they're doing on the graph before we can begin. Okay? Alrighty, it says how many goals in all did Alex and Reggie score? So let's go find Alex. Okay, I've got Alex in green here. So I'm going to focus on Alex in green. I'm going to focus on Reggie in pink. Let's take a look at Alex's score. Alex's bar graph goes all the way up to here. It's after 16, but it's before 20. So it's at this halfway line. Okay, I know that half of 4 is 2. Half of 4 is 2. Okay, so I have 16 and then I've got to add 2 more. 17, 18. I could also do it by looking that Alex is not at 20. Alex is 2 below 20, so 20, 19, 18. Okay, so Alex has 18. All right. So down here, I have Alex has 18 plus I've got to find Reggie's score. Okay. Reggie's score is right here. Reggie's in pink and he goes up and stops right here. Now in my mind, and it's hard for me to just see where he's at. So I like to trace that line over. So I'm going to trace over to see where it's at. And oh, look at that. Reggie's right at 16. So Reggie scored 16 goals. So Alex has 18 goals and Reggie scored 16 goals. So now we've got to figure out what those equal, okay? It's hard for me to add up when they're sideways, so I like to stack them on top of each other so I can see my regrouping. So I have 18 plus 16. 8 ones plus 6 ones is 14 ones. That's a 10. Put down my 4.
Plus 1 is 3.
Terrence, thank you for letting me teach. 10 plus 10 plus 10 is equal to 30. So there's a 3 in my tens place. So my answer is 34 purple unicorns flying through space. So we're going to add that little label, purple unicorns flying through space. And yay, we've got our correct answer. They scored 34 purple unicorns flying through space. Senkyu, why are you smiling?
I don't get it.
Oh, well, what did they score? What should it say?
It should say they scored 34 hockey goals.
Oh, you're right. When there's a word problem, I got to have a word in my answer. If you don't have a word in your answer, I'm going to assume that you have purple unicorns flying through space because thinking about those makes me happy. So I'll be happy, but you'll be wrong. So we must have that label of hockey goals, okay? 34 hockey goals are what were scored. All right. Any questions on that one and why we got that answer? Yes, Terrence.
Can you slow down?
Sure. Okay. Number 2, explain how to find how many more goals Alex scored than Cindy. Okay, how many more did Alex score than Cindy? Now, guys, we're going to work smarter, not harder. We already know about Alex from this problem. Alex scored 18. So I'm going to take my pen and I'm going to write 18 over there by Alex because I don't have to count him again. Alex got 18. Okay. Before we can tell how many more Alex got, we have to know how many Cindy got. Okay, so we're going to take a look at Cindy's graph. Here's Cindy. We're going to follow her graph up to her top line. and I'm going to trace it over. It's between 12 and 16. We're counting by fours. I know that half of 4 is 2. So I'm going to add 2 to 16. 16, 17, oh, to 12. I said that wrong. My bad. I was thinking about Alex. Halfway between 12 and 16. So we're going to add 2 to 12. 12, 13, 14. So Cindy scored 14 goals. Okay. So now that we know that Cindy scored 14 goals, we can compare them to Alex's goals. We know when we're seeing who has more than someone else, we know that we are going to subtract. Our problem asks us to explain how to find how many more goals Alex has than Cindy. So let's type that explanation. We will subtract 18 minus 14 to see how many more goals were scored by Alex. I'm going to make that a little bit smaller so we can see it, and I will also place that in the chat for you in case you get behind. So we will subtract 18 minus 14 to see how many more goals were scored by Alex. Miss Sousa, you didn't tell the answer. You're right, guys. It didn't ask me to tell the answer. It says explain how. So I've explained how I'm going to do that. Okay. Any questions? Aiden G.
I'm confused on how you put it in the middle of 12 and 14, 12 and 13.
The middle line that's in
and
between.
it made 14.
Sure. Okay. So the question is, how did you get to 14 when it's in the middle of 12 and 16? So Aiden, I'm going to erase all this so that we can see it a little bit better. Okay. All right. So do you understand, Aiden, how we are counting by fours on this scale?
Yes.
Okay. So do you understand that if I have 4 and I cut it in half, half of 4?
Oh, I understand now. So when you count by fours, you can get.
Yep. And in the middle of 4 is 2. So when we see this line right here in the middle, it's plus 2. So 12 plus 2 is 14. Does that make more sense now? All righty, awesome. Let's take a look at slide 4. We're back to pictographs. So we have switched from bar graphs to pictographs. In 3 through 5, use the picture graph. Here's our picture graph. Which area has lights on for the most hours each week? Now, I've shared with you several times. I want to make sure you remember, before you start working with the picture graph, look at the scale. Okay? This tells us down here that each full light bulb equals 10 hours. So we're counting by 10. A half light bulb equals 5 hours because half of 10 is 5. Okay, so we are counting by tens. Which area has lights on for the most hours each week? That would be which one has the longest section of picture graph. So let's check. Exercise room stops here. Locker room goes all the way to the edge. Swimming pool stops here. Tennis courts stop here. So we can see that the locker room has more light bulbs representing more hours. So which area has lights on for the most hours each week? That is the locker room. Any questions on how I found that answer? Okay. Next up is question 4. Question 4 says, which area has lights on for exactly 50 hours each week? Now, I could start counting every single one of these, or I can work smarter. I know how to count by tens. And I know if I need to get to 50, show me with your fingers, guys, how many tens is 50? Christopher's quick with it. Lee is there. Miss Bram's got it. Terrence has got it. Sinq's got it. Levin's got it. Yes, it's 5. So which one of these has 5 full light bulbs? Well, let's see. Exercise room has more than 5. Locker room has more than 5. Swimming pool has 1, 2, 3, 4, 5.5. Nope. Tennis courts, 5. 10, 20, 30, 40, 50. Boom! Tennis courts it is, because there are 5 light bulbs here. So which area has lights on for exactly 50 hours each week? That is the tennis courts. Okay. Oh yes, Aiden Hampton, a question.
Can we use the text box also?
Yes, you can. You don't have to type or write it with your finger. That's totally fine. In 1 week, how many more hours are lights on in the exercise room than in the swimming pool? Okay, so we're comparing how many more in the exercise room than the swimming pool. Okay, let's count this together, and I'm going to change colors so it's a little bit easier to see there. Exercise room, swimming pool. Okay, we're going to count the exercise room. Remember, each light bulb equals 10 hours. If you guys count by ones, I'm going to send this back to you because it's counting by tens. You've got to pay attention to those scales, okay? Count by tens with me. 10, 20, 30, 40, 50, 60, 70. Miss Sousa, there's a half a light bulb. What's half a light bulb? Oh, I'm so glad you asked. Look right here. It equals 5. So 70 plus 5 is 75. So the exercise room uses the lights for 75 hours. Now we're going to count the swimming pool. We can see that the swimming pool is less because there are less pictures here, but we don't know how many. So let's count. 10, 20, 30, 40, 50 and a half. Half of 10 is 5, so that's 50 plus 5, 55. Okay. So the question is, in 1 week, how many more hours are lights on in the exercise room? Let's write the exercise room hours. That's 75 hours. Than the swimming pool. That's 55 hours. So we are going to subtract to find the extra that the exercise room uses. 5 subtract 5 is 0. 7 tens subtract 5 tens is 2 tens. 2 10s and 0 1s equals 20. Somebody tell me why I'm not done. Yes, Aiden Hampton.
You have to label it.
I do. What is my label? What are we talking about on this graph?
Light bulbs.
20 light bulbs. That's the picture. What do the light bulbs represent? Look at your scale. Look down here at the scale. Each light bulb equals what?
10 hours.
Hours. That's right. So it's 20 hours, okay, of using those lights. Awesome. Thank you, Aiden Hampton. Any questions on that? All right. I'm going to steal 4 minutes of your time. Okay, 4 minutes of your time. Oh, it did. It said in your breakout room. I'm sorry. I got excited. We just kept going. 4 minutes of your time to look at slide 6, and then you guys are on to your independent work. Okay. Slide 6, it says with your teacher. How many units does each grid line on the graph represent? How do you know? Okay. Now, some of y'all are saying, oh, it equals 10 because look, they're counting by tens. And I'm so happy that you are using the scale, but this does not ask what is the scale. It asks what are the grid lines, okay? These grid lines, look, trace one of them. Go in between 0 and 10, okay? So the grid lines represent half of 10. Show me with your fingers, what is half of 10? Christopher is quick with it today. Guys, I can see your fingers. I can see your fingers. Show me with your fingers, what is half of 10? 5 it is. So each grid line represents 5. How do you know? Because it's half of 10. So let's type that out. Each grid line represents 5 units because half of 10 is 5. Each grid line represents 5 units because half of 10 is 5. We looked at the scale. The scale was 10. Half of it is 5. Okay, any questions on why that is the correct answer? Okay. Your independent work today is slides 6 through 10. You are going to look at the graphs. You are going to answer the questions. Okay, you are going to look at the graphs. You're going to answer the questions. I want everybody to raise your right hand. I'm waiting on Camille. I'm waiting on Justin. I'm waiting on Aiden Hampton. Right hand raised. All right, repeat after me. I promise I will count by the scale. Say it together. I promise I will count by the scale. Okay, good. I'm so glad that you all promised that to me. I'll make sure that you keep your word. And if you count by ones and you say that this is 4.5 houses, I'm going to send it back to you because you didn't keep your promise. Okay, we're going to count by the scale. That is what 3rd grade is. You guys have counted by one since kindergarten. We are moving on. Okay, counting by the scale. So your independent work today, look at each question. Make sure you count by the scale. As always on slide 11, success criteria.